When asked to reduce and state restrictions again, we're going to do the same thing. As tempting as it is to want to start canceling and dividing, remember the first thing we want to do, basically anytime we see a polynomial, is just start factoring away and see what can happen. In my numerator alone, 6 is the GCF of my coefficients. Lowest exponent is a t. Factor it out as, I have a 3t plus 1. Remember, if I distribute that, 6t times 3t is 18t squared. 6t times 1 is 6t. There's my GCF factored out in front. Unrelated, let's look at the denominator. The biggest number that goes into 6 and 15 is 3. Still have the lowest exponent of 1, so just that t. End up with a 2t plus 5. Now, again, my restrictions are just going to be in the denominator. I won't even care about the numerator. Since the binomial is the same, leave it. But there is a little bit of reducing I can do. Think of just my coefficients alone. 6 over 3, divide by 3, divide by 3. I can have 2 over 1. Canceling out my t's, divide by t, divide by t. What I'm left with is 2 parentheses 3t plus 1, the polynomial, divided by 1 times, but that'll just leave it the same. Here, I won't even need parentheses. And it's important to notice, because Math Excel is really going to care, up here I needed parentheses because that coefficient applies to the entire numerator. This coefficient applies to just that term, just that 2t. So this one would need parentheses. I could distribute it, but I don't think Math Excel will want you to. The denominator, just don't put that 1 and don't put the parentheses for the same reason. Now, I also need to state my restrictions. Back here when it's factored was the easiest form. I can think of it as equal to 0, but just think of it as each factor. This one, kind of obnoxious, one of the last problems we did, when I have a binomial, 2t plus 5 equal to 0, I got to use some inverse operations, minus 5. Those coefficients, whenever I have a leading coefficient, just know it's not going to be harder, but it just means it's going to be more additional work. Divide by the 2, t can't be negative 5 halves, right? One of my restrictions up here, negative 5 halves. But that's not the only one, even though it canceled. Look back here. If I were to say set 3t equal to 0, divide 3 by each side, remember 0 divided by 3 when 0 is in the numerator, that's a good thing. That's my easy one. 0 divided by 3 is just 0. T also can't be 0. And look back to the original problem. If I plug in negative 5 halves, yeah, I promise you, if you square it and you get a common denominator and you add the numerators and you reduce, okay, yes, that's going to cancel, and yes, that's going to give you 0. But if I plug in 0, and 0 is kind of the more apparent one, just like one of the examples we had in one of our last few videos, without a constant, 0 will always be a solution because 0 squared, 0 times 6 is 0, 0 times 15 is 0, plus 0. 0 most apparently gives me a 0 in that denominator. Even though it canceled, and even though 0 would have been okay over here, it still gives me a 0 in the denominator here, so it must be a restriction.